The next property of integrals, remember this just means the area under the curve from A to B, or the area between the curve and the x-axis from A to B. If I were to draw a picture, same picture that I've been drawing, if this is A and B, then this area is represented by this integral. Alright? What if you have a C value in between? A is like, what if you have a C value in between? Well, then you could also do from A to C, right? From here to here of f of x. That's just this area, right? Whee! And then dx. Add it to the area from C. Again! So it's been 6 minutes between the last time. Okay. C to B of f of x dx. That's only if C is in between A and B. You can split up the integral. That's what I'm saying. It's like if you have a discontinuous function or a piecewise function, you can split up the integral and just add the two areas together. Hopefully that makes sense. So this works if and only if C is in the middle. If C is in between A and B. So what does that look like if I have like a small example? Well, you try to come up with something. What's in between 0 and pi?
Pi over 2.
Yeah, pi over 2 is in the middle. So this is the same thing as the integral from 0 to pi over 2. All the way, well, it's of cosine, of course. Keep the same integrand. And add it to the integral. Well, start where you left off. Pi over 2. All the way until pi. And same integrand. So there you go. That's what that means. So just take the area halfway and add it to the area of the other halfway, or any distance in between. It could be 0 to like pi over 6, and then from pi over 6 to pi. It doesn't have to be directly in the middle. It just has to be in between. Okay, cool. That's that property. Let's move on. For this next property, we gotta review a little bit for like translations of functions. So if I'm thinking about the graph of f of x and I have something being subtracted on the inside, this just corresponds to the graph of f of x shifted to the right by c units. So let's just have that in mind. So that's what that means. So like a little quick example here. If I had y equals x squared, that graph is just, that's not it. Just like that, maybe I should do an f of x. So there we go. If I have that, if I have, let's say, g of x is just this shifted over, x minus 3 quantity squared. If it's on the inside of the function, remember, on the inside. If it was on the outside, like a minus 3, that would shift it down. So that's different. And that's actually another property we're going to address. But here, it's just 1, a 2, a 3, and it's the same graph. It's just shifted to the right. So that's something to recall. Little note there. All right, we're going to use that. This one's actually maybe the trickiest one to recognize because it's kind of weird, but it's actually really helpful on some problems. They get kind of tricky, but it's kind of satisfying if you catch that it's just a function shifted over. So that's shifted to the right. All right. So what's the property of integrals that we're going to look at? So if you take the integral and you're shifting the function to the right, and you have a plus c. This is weird. A b and b plus c. So let's break this down. Take it slow. This part, the integrand, corresponds to a graph of regular f of x that's shifted to the right c units. Right? Because when you have it on the inside of the function, remember it's kind of like opposite. You don't go left because it's negative. You go to the right because it's on the inside of the function. So this graph is shifted to the right by c units. But then the limits of integration are also shifted to the right by c units.
Mr. D, how come you don't do a minus c?
Well, on the inside of the function, the rule is if you want to shift to the right, you subtract, right? You get a negative value in there, and it kind of changes it. But this is not any type of function, it's just a constant. So if I want to go to the right of a constant, I would have to add. So that's what that means. This is just everything shifted over to the right. I hope that makes sense, but that's the same. It's just the area shifted over. It's the same as the integral from a to b, right? If you unshift the integrand or the limits of integration, you can also unshift the integrand, which is just f of x dx. Hopefully that makes sense. Maybe I'll make a little example. So what does this equal? Maybe you should pause it and try to figure it out. This is just the square root function shifted to the right by 4 units. So if I want to unshift it, I would just have the regular square root of x function. Hopefully you paused it already and tried it. So how would the limits of integration shift? Well, from here going to here, I'm shifting back, right? This is to the right 4 units, and this is back to the left 4 units, right, to get the original. So I'm going back to the left. So I have to make these go to the left. So what's 7? I'm shifting 4 to the left, right? I'm shifting 4 to the right for the function, but to go to this, I'm shifting back to the left. So this has to go back to the left. So that means 7 minus 4 is 3. And this one's 3 minus 4, which is negative 1. These are the same thing. They're the same area. Maybe we should draw a picture to represent this. I think I want to. I'm going to double check this though. So let's see. I'm just going to graph this real quick. This is shifted to the right 4 units. 1, 2, 3, 4. The square root function looks like that. And I'm getting the area. This actually doesn't make sense. Maybe I should have changed the limits of integration. Alright, so I changed it from 5 to 6. That way the picture makes sense. Because otherwise there would be no area. So this is 5 and 6. So the area that's represented by this integral is right there. Yeah? Yeah. Okay. So that's from 5 to 6, right? 4, 5, 6. Okay, so that's what this looks like. And so what would I'm shifting to go from here to here, I'm shifting to the right. So, no, sorry, to go back, I'm shifting back to the left, yeah. So that means this has to go to the left, so minus 4. Now let's see. I mean, I'm pretty sure I just thoroughly confused some people, but hopefully after I draw this picture, it'll make sense. So this goes together, and what's the picture for this? Well, I have the regular square root function, right? It's starting at 0, and at 1 to 2, I have this area. Right? It's the same thing. It's the same as this, except for it's just shifted, to the shifted back. This one's shifted to the right. It's the same as this area, shifted back. So hopefully that makes sense. I don't know if it does or not, but I'm going to be done with this video with maybe one more property, I think. I hope. I don't know.